Okay, so some of you can be sitting here thinking, yeah, I got this, I'm awesome. Brilliant. I'm excited about that. But too many of you are making careless mistakes when it comes to this. Whether you were just rushing it because you were running out of time, I don't know. How was one? Okay, so there shouldn't, you shouldn't have said that, because there shouldn't have been any errors in things like this.
We're doing 7, 8.
So, well, we're going to do all of them. Okay? So, when it comes to expanding stuff, they're the areas that there could be little mistakes. Okay? Now, when it comes to checking, you might read through and just be looking at the stuff and thinking, yep, I did it right, I did it right. Well done, me. But it's really hard to catch your own mistakes when you're doing these things, if you're looking at them. So my suggestion to you is that when you are checking your work, if you have time, try and cover up what you've written and do the work somewhere else or next to it, in pencil probably, because you've done it already in pen, and then just check that the two match. If they don't match, then something's gone wrong with one of them, maybe both of them, who knows. But it's hard to look at mistakes from your actual work because you're looking and going, yeah, great, I've done that. Okay? The order doesn't matter. We need to make sure that we're expanding a pair of brackets first, and then that result is then going to be multiplied by the third one. Should I do the first two together? Okay, so if I expand this, we're using FOIL. So we've got 2x squared plus 6x minus x minus 3. Okay, so that's the first outer, inner, last. Okay, you're multiplying those terms. I can then join these together to save a bit of time. So that's 2x squared. I've got 6x, take away x, so that's plus 5x. Now, each three of these things have to be multiplied by both of those. There's no special FOIL to help you remember this. You just need to make sure that you are multiplying each of them by each other. I tend to multiply everything by the first one and then multiply everything by the second one, but it's up to you. So I would have 2x cubed plus 5x squared minus 3x. And then to multiply everything by the minus 5, I have minus 10x squared minus 25x plus 6. Okay, so that's those three things multiplied by the x, then those three things multiplied by negative 5. You're then going to join like terms. I've only got one term with an x cubed, so that's there. I've got positive 5x squared minus 10x squared. What does that give me? Okay. I've then got negative 3x minus 25x. And then plus 15. Okay? So just take it baby steps. Don't rush these things, because if you make a mistake too early on, the mark scheme doesn't allow any it doesn't allow any marks to be allocated later on. So you have to, when you're marking the external exams, you must follow the mark scheme. And if it tells you you have to stop at a certain point, that's it. You're in doo-doo, really. You get nothing. Okay? I can't remember what the mark scheme was. I followed it. Okay? Right, so that's that one. This one's frustrating. Okay? Because I thought that we got this sus. The more frustrating thing is that some people were trying to factorize it. Why do I know that this question does not allow me to factorize this question? No, because we can still factorize. That's a quadratic. So we learned enough for factorizing. There's something else about this question that should highlight that I cannot factorize it. Okay?
Because it says give your solution correctly.
Good. This thing here is the thing that immediately tells you do not spend any time trying to factorize this baby, okay? Because you cannot. So straight away we know that we're going to be using the quadratic formula, okay? You get given the quadratic formula, it's there at the front of your papers. So you need to identify your values. So the value of A in this case would be 3, B would be 6, and C would be, And then you're just sticking it in the formula. So it's minus b plus or minus the square root of b squared minus 4ac over 2a. So minus b. So we're looking at our value, and that's going to be negative 6 plus or minus. Okay, and then you're going to have positive 6 squared minus 4 lots of 3 lots of negative 5 over 2 lots of 3. Now remember, I said chuck it in there, and then what should you do? Right? Use your calc. Remember, you just, then once you've got, that's why I think some people are getting frustrated that they've got these fancy calculators and they're not using them very much. It's because you are reluctant to use them.
I love it.
So, pardon?
I love that calculator.
Good. Because they do a lot for you. You don't have to type everything into your baby calcs. The baby calcs are wonderful for some things because the buttons are a little bit easier to find. But the more you use those big calculators, the easier you will find it in your GCSE and then moving on to whatever course you do after that. Okay? So please bring them along and please practice with them. If you use the big calcs, you find the correct place, you just have to enter 3, 6 and negative 5. You get the 2 answers straight away. I have 0 on. No idea what the answers are. Did anyone get it right?
No, I just 2.63 and then 0, 4, 3, 3.
No.
6, 3, 3, 2.
6, 3, 3.
Oh, that's why I'm
Okay,
0.
and again, it asks for the 3, 6 big, so make sure you're rounding to the appropriate level. Okay? Right, so next one I'm thinking is this circle geometry one. This wasn't so awesome. I mean, some people, don't get me wrong, not everyone bombed out on these, but enough to you that I'm thinking we probably need a little bit of research going on. So we've got a circle. Remember, with circle geometry, there are lots of reasons, and maybe it's a point where you haven't had time to learn them. Maybe it's going to be a situation that by the time the external exams come along, you've forgotten everything you learned this year. Who knows? But the only reason you get to know them is because you do questions over and over again. So if this is one of your bugbears, then please try the odd question every now and again just to keep it fresh up here. If they've shown you the center of the circle, it means that it's probably important, okay? And there are a couple of rules that use the center of the circle. And one of them is if a line goes through it and cuts it in half. Well, clearly we don't have that in this situation. This line here, they've told us, is a tangent to the circle. So that's probably going to be becoming useful. Yeah, okay. What does it ask us for? Find the size of NON. Now, if you don't know which angle you're looking for, then you're individual already. Do we all know where NON is? Okay, NON. So we're looking for this angle here, yes? Anyone tell me? And what?
54, because an angle of the center is the twice the angle of the circumference of the center.
Okay, ixnay on the last digit. Okay? So the angle at the center is twice the angle at the circumference. Now, I appreciate that lots of you were trying to get that message across to me. It's just that some of your words you were using were just not appropriate and not enough for me to allocate the marks. Okay? So this one is a 54, and it's the angle at the center is twice angle at the circumference. Now you would use the at sign. Just explanation. Okay? So the angle at the center is twice the angle at the circumference. The end will stop. No more needed. Okay? Lots of people are saying subtended by the same arc. That's the both I want. Okay? And last one, to find the size of angle NMQ. So, hello, lost it. It was all gone wrong. We have returned. That's it. That's okay. So what? NO.
No.
Oh, it is N and Q. Shut up. N and Q. Okay. So we want this angle here. Any suggestions how we might go ahead? Alternate segment theory. How's that? Hello? Anyone? No one? No. There's a couple of different ways you can do it.
90 minus 60.
Why did you do that?
It's 27. Because the 27
Why?
it's a birthday.
Not very tight.
Oh, it's an interior
I don't think anyone is wrong. I just want people to be confident in what they're saying.
I should have done that.
Oh no, it's the same.
Alternate,
Yeah,
like,
alternate segment theory.
Okay, so don't get all feisty. I said I haven't said anyone is wrong. Hey, so you've got a couple of choices. One is that this angle here is going to be equal to this angle here. Okay, it's that windsurfing one. That weird one. That's what I call windsurfing. It's called the alternate segment theorem. So this exterior angle is equal to the interior one opposite. When you have a triangle that's 3 points to a tangent, so all 3 points are on the circumference, then this angle here is equal to this one. Okay? Essentially, it's the angle that hits the line. Sorry, so if this hits this line, it's got to be the other angle. Okay, so it's not the one touching that line. Okay. So there's that option. What other option could you use? Any? What do you know about this triangle here? Yeah, it's nice obviously. So if you know that one, you can work out what these two both are, yes? Because we know they add up to 180. Tanya, no. So we know they add up to 180, so we can find this one because we know they're equal to each other, yes? Well, the red one and the blue one, what's special about the red and the blue? Why? Good. So the tangent meets the radius at 90. So we know this total angle would be 90. So again, you could do some subtraction to get that.
Where is the back of this?
You want to blow it?
No, but it's like.
Now, whichever reasons you use, okay, so there are several different options when it comes to giving reasons. Okay, but if you've used multiple reasons, so for example, if we use that one we just talked about, you would have to take all of those reasons. Okay, so I was looking for alternate segment theorem, but as I said, if you had all of the reasons for the others, that could have been accepted too. Right. So I know you all have got some hate angle reasons, but that's the phrase. All right, next one, number 9. Because people made errors here, either one or both of them. Okay. Wait, of course.
The last one you said it was because the windsurfing?
Alternate segment theorem.
So the windsurfing, so the exterior is equal to the interior? The exterior.
No, you had to say alternate segment theorem. All right, simplify fully. So this is a negative 1/4 outside, yes? What's the rules of indices? What do we do when we have something, a power outside a bracket? I multiply. When you say you multiply it, what?
Everything inside the bracket gets
Okay, so I'm hearing everything in the bracket gets multiplied by that power. No. No. Okay, so Aria has just said the 256 is raised to that power. Okay, because remember, big numbers are raised to powers. and then indices are multiplied. Okay? So this is raised to this power is multiplied. This has no big number, so we're just going to have 8 multiplied by negative 1 quarter.
Is that the answer?
Well, the answer to that is okay?
So
You have calculators, you just plug it in your calculator. I don't expect you to learn what 256 to the negative 1 quarter is. You just need to put it in your calculator. That's why you have it available to you in these exams. So what is 256 to the negative 1 quarter?
wait, why did you say
0.25.
So is it, why did you have to do what, sorry?
I know, I just got it.
Okay, so that's 0.25, so that's this part here. Okay, then we need to find out what 20 multiplied by negative 1 quarter is. And then you can keep it over here, y, and then you've got 8 times negative 1 quarter. I think that would have got you full marks.
I definitely think it's all bad.
Okay? I think it would be a good thing. I'm hoping I did. I marked gross. Okay? So that should not be challenging as long as you remember to raise things and multiply if they're outside of bracket. Okay? You have your it doesn't look nice, don't get me wrong. Looking at it, it looks awful. You might think I have no idea. But the rules apply whether they look nasty or they look okay. And this one I know caused a few issues. Okay, so we need to write it as a single fraction. So we've got average fractions, we're subtracting them. What's the rule for adding or subtracting any fraction? Common denominator, okay? But remember, if I have something like 1/6 plus 5/12, am I going to say that my denominator is 72? Why not?
Always.
Because we want our lowest common denominator, okay? So we want to find anything that's common, and the reason we wouldn't choose 72 is because I can say that this is actually 2 times 6, okay? So I have the 6 that's common, yes? So, we want to see, is there anything common between these two? Well, I can't tell just by looking at it. So what are we used to doing when we see expressions like this? What are we used to doing? We used to factorize them, okay? So let's try factorizing them. This is a special one. Why is that a special one?
Square.
Is it different to 2 squares? What is going to go in my 2 brackets? 3x plus 5 and 3x minus 5. Thank you. Okay? So that's that first one factorized. The second one. What's common there?
2 3x plus
2 brackets 3x plus 5. Now, admittedly, this second one is a lot easier to factorize, yes? You agree with that? So having factorized that, if you've been asked to write this as a fraction as simple as 4, that tells you 99% of the time there's going to be something common with this one, okay? So that in itself might help you to, so seeing that it's 2 and 3x plus 5 tells you that either the 2 or the 3x plus 5 is going to be common over here, which might help you recognize that was the difference of 2 squares. It may not, I don't know, but that's another thing to think about. Alright, so once we've factorized, we want the lowest common denominator. So we want the lowest thing, the lowest number of things that we can have in our denominator. So I need to have a 3x minus 5. I need to have a 3x minus 5, and I need to have a 2. Okay, I haven't put it in the order. I've put it in the order. Do you all recognize that?
What would be the normal order?
2 in the front. Do we see that? So anyone sitting there going, what the heck is she doing? No, we're good.
Um,
So I've got two things here, I've got two things here. What's common? These two, well, what's the least things I can have? I need both of these two and this one. Okay? Because that's already common, that's already been taken care of. Yes? So that's going to be on both of them. And that's way. So then you say to yourself, right, what did I have to do to that first denominator, that first fraction? I had to multiply by 2. Remember, whatever you do to the bottom, you must do to the top. What do I have to multiply the second fraction by? 3x minus 5. Again, top and bottom. So my denominators are good, because that's what I wanted. So my numerators is going to be 2 times 1.
so they just cancel each other out. Like the 3x minus 5. So it's 2, then you plus it out. Then 3x plus that, and then it's just 2. Like, why would they just cancel out?
Okay, what counts out where? So,
Can they not cancel out if they're both on the bottom?
no. But that's the aim of the game. We're trying to make the bottom the same in order to be able to join it together. Okay. So then I'm doing 1 times this, so that's 3x minus 1. Okay. So we've got the same denominator. Now we can just join our numerators. The issue here is that we're subtracting the second one. Okay? So actually what's going to happen is that I've got this as my denominator. I'm going to change the order now. So I've got 2 here. I've got take away 3x, but then I've got plus 15, where 15? Plus 5.
There's 7 minus.
Okay? Because I'm taking away the negative 5. So then I just simplify that to be 7, take away 3x, or negative x plus 7. I don't know. Okay, so the final answer. So a line has equation 4y minus 6x equals 33. Line M goes through the point 5, 6 and the point negative 4k, and we know that L is perpendicular to M. Okay. So the fact that they're starting to talk about perpendicular things, what are we going to probably need to establish? Of what? Okay, so firstly, we know that perpendicular things, we're thinking about negative reciprocals, but we need to establish the gradient of line L. Okay? So looking at line L, it's got the equation 4y minus 6x equals 33. Can I tell by looking at it what the gradient is? What do I have to do to this expression? To rearrange it into which form? Yeah. Okay, so we're rearranging it to be y equals mx plus c, and once we've done that, this value here will tell us the gradient, yes? So let's do that. So I've got 4y equals, I need to add 6 to both sides. And now I need to divide by 4. Remember, with equations of straight lines, you want to do separate divisions here. Okay, it makes it a lot easier to make sure that you're not missing something. So what's my gradient of line L?
Minus 2.
What's my gradient of line L?
For 1 square.
What's my gradient of line L? 6 over 4 or 3 over 2. Okay, that's what I said. You also said negative 2 over 3 first of all.
I was looking at M.
And hence I say gradient of L louder. So then other people started saying stuff as well. Try and leave them as improper fractions. Don't go to decimals. It makes your life a lot harder. And if you start leaving things if you leave things as decimals in fractions, they will be marked as wrong because you cannot have something like that. That is incorrect math. Okay? So do not leave things as decimals, leave them as simple fractions. Try and simplify them if you can. So I would leave my gradient as L as 3 over 2. And if L is perpendicular to n, it means that my gradient of m would be what, Emma?
-2 over 3.
Okay? So if we know the gradient of L and we know it's perpendicular to m, then we would find its negative reciprocal. Okay? So that's its negative reciprocal. Right, so that's established what the value of the gradient is. Now, they've told us that m goes through 2 points. Okay? And they're asking us to establish what's this value here. So how would we find the gradient of a line if we know 2 points that it goes through? How do we find the gradient of something? Okay? Because remember, it's rise over run, yes? And the rise is always given by the y values, and the run is always given by the x values. Now, it doesn't matter which one's 1 and 2, but remember, consistency is the key. So whichever one you start with, that's the one you must start with when it comes to the other part too. So, what's your right?
I can pick
K minus 6, okay, well, I'm going with that because that's the first one I had. So K minus 6, okay, so I've started with my y values, K minus 6 over negative 4 minus 5. Okay, so we've got K minus 6 over negative 4, take away another 5 is negative 9, yes? I know that K minus 6 over negative 9 is equal to negative 2 over 3. Because we just established that, yes? So we established the gradient of m because we knew it was perpendicular. We then established the gradient of n using the formula, using the 2 coordinates. So those two must be equal to each other. I now need to find k. I've got a fraction equals a fraction, which means that I can cross multiply. So I've got negative 2 multiplied by negative 9 equals 3 lots of k minus 6. Notice I've had to use brackets because the 3 is multiplying by both of those two things. Negative 2 multiplied by negative 9, oops, is not negative. And then I've got 3k minus 18. Solving this, you're adding 18 to both sides, and then dividing by 3. Okay, so k is 12.